bonding. Welcome back again to God from the Academy. So don't forget to subscribe. So let's answer this question that came in Science Paper 2, 2019 ECZ syllabus. So that's chemistry. So it is saying the diagram below shows atoms of sodium and chlorine. So this is sodium, right? Yeah, Na. And this is chlorine, Cl. So these are the diagrams. So now the first question is, state the type of bond that exists in the compound formed when the two elements combine. So when we combine sodium and chlorine, what type of bond is formed? So here you need to understand this summary. So if you haven't understood the types of bonding that we have, here is the summary. The first type is covalent. So covalent bonding is the one that is formed between nonmetals. For example, chlorine and chlorine, or hydrogen and chlorine, or fluorine and hydrogen. Both of, or rather all these elements are nonmetals. So the type of bonding that occurs between them is what is covalent. So when you're talking about covalent, you're talking about nonmetals pairing together. Okay, nonmetals sharing electrons. That's covalent bonding. Then when we have ionic bonding, that's now between a metal and a non-metal. Once you see a metal and a non-metal, you should know that the type of bonding is what? Is ionic bonding. The last one is metallic bonding. That's the type of bonding between metals, or the one that occurs in metals. So metallic, just like the name suggests, metallic, from metal, so it's for metals. Then ionic, metal and a non-metal. Then covalent, between non-metals. That's the power of summary. Don't forget. So when they say sodium and chlorine, sodium is a metal in group 1, the alkali metals. Chlorine is a non-metal in group 7, the halogens. So between a metal and a non-metal, I said what? It's ionic bonding. So as simple as that. Here you simply say, so you write here to say this is our A. So you say for A, ionic bond. Since they used bond, what type of bond? It's an ionic bond. The next question, draw the structure of the compound formed when sodium and chlorine combine. So for ionic bonding, this is how we do. You just get this. You understand that when they are bonding, sodium loses one extra electron, the outermost shell electron. This one, it loses it. So it remains with these two shells. The outer shell is gone because the electron is transferred to the what? To this chlorine. Okay, so here is how you express it. You draw exactly this, but you remove the outer because the electron is gone. And you should use the pencil. Here I'm using the pen, but you should use the pencil. So you're going to draw the sodium. It's like Na. So this is, you just draw exactly the way it is. Na. In the first shell we have 2 electrons. Then in the second shell we have 8. So this is an electron, this is an electron, like this. Then the outer one, this one now is gone. So to express that, you put them in square brackets like this. Then you write positive. Since it's positive 1, but 1 we don't write, you just write positive to mean 1 electron is lost. Then you also draw now this chlorine atom. So again, it's going to be like this, just next to sodium. Now look here, they've used dots. Here they used crosses, now here it's dots. So you also follow the same thing. Then a second shell does 8, and that's according to the law of electronic configuration. Then the outer outer now. So the outer, if you count, it has 7, 2, 4, 6 plus this one, 7. So you write them, you draw them. Okay, then that one that got transferred from sodium, which is a cross, you indicate it, you add it here. Okay, so it should be different according to the ones on sodium. In this case they are crosses. Then here you also write it like this, then you say negative to show that it has gained one extra electron from sodium. So this is the bonding, this is what they wanted. Then the next question, state the chemical formula for sodium chloride. So sodium chloride, the way we write chemical formulas, you write sodium, the valence number is 1. You write chlorine, Cl, the valence number is also 1. Then you cross them. So sodium, this one from chlorine comes here according to the arrow. Then you write chlorine, this one from sodium comes here. But because these are ones, we don't write 1 always. So you just write it like this. So this is the chemical formula for sodium chloride. Okay, this is another topic, writing of chemical formulas. You should, it's a very small topic, I think 1 page, but it's there in chemistry. So you just have to revise, and this is the revision. This is what you do always. So if this had 2 here, the 2 would have come here, so it would have been Na2Cl, but because both are 1, so it's like this. Then we go to the next. Explain in terms of bonding and structure why sodium chloride has the following properties. Number 1, a very high melting point. You understand that these are positively charged ions, and since they are positively, the forces of attraction between them are so high. To break them, you need strong heat. So for C, you say because of the strong forces of attraction between oppositely charged ions. So you say, now you can finish. This requires high amount of energy to break these forces. Hence the high melting point. So you understand that between the positive and the negative charged ions, the forces of attraction are so high. So to break them, you need high amount of energy. Hence, it has a high melting point. The last question: why it has high electrical conductivity when in molten? When in molten, it means when it is melted. Okay, it was in solid, then you melt it. So it becomes more like a liquid, but it's not really a liquid, it's different. Because a liquid, you understand that there is, in most cases, there is water. But this one, there is no water. You just melted it. It undergone melting. So when it is in molten state, the electrical conductivity becomes high because electrons now are free to move, unlike in the solid where they are not free to move. So when they are in molten, electrons are free to move. So this was 1, this is 2. Because in molten state, electrons are free to move and carry electricity. So that is the reason why it has high electrical conductivity when in molten state. So this was the question. I hope you've gotten how I have summarized everything. Don't forget to subscribe.